Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at graphing exponentials. So, exponentials have an equation of the form y equals a to the power of x plus b. Here the x is part of the power. The unknown is part of the power. That's what makes it an exponential. So the kind of graphs we're going to look at are graphs like y equals 3 to the power of x, y equals 3 to the minus x, and so on. So to graph these, we can start by using a table of values. So we choose the x values and we will substitute to find the y values. So let's start here. So if x is negative 3, 3 to the x, 3 to the negative 3 is 1 over 27. You can just use your calculator for that. 3 to the negative 2 is 1 over 9. 3 to the negative 1 is 1 over 3. 3 to the power of 0 is 1. 3 to the power of 1 is 3. 3 to the power of 2 is 9, and so on. So let's look at 3 to the minus x. Well, if x is negative 3, this would be 3 to the power of negative 3. It will be 3 to the power of positive 3. And this will be 3 to the power of positive 2, 3 to the power of positive 1, 3 to the power of 0, anything to the power of 0 is 1. So this would be 3 to the negative 1, which is 1/3, and so on. So what you can see here is that for these two rows of the table, they're just reversed. 1 over 27, 27, and so on. What about 3 to the x minus 4? Well, we can just take each of these numbers and subtract 4. So if you put this on your calculator, 1 over 27 minus 4, you get about minus 3.97. 1 over 9 minus 4, you get about minus 3.89. So 1/3 minus 4, you get about minus 3.67. Then we just go 1 minus 4 gives us negative 3. 3 minus 4, negative 1. And then so on, you'll get 5 and 23. Okay, so let's graph each of these. Remember that each is a point. So if I want to graph y equals 3 to the power of x, I have points negative 3, 1 over 27, negative 2, 1 over 9, and so on. Well, let's start graphing this point, which is a bit easier. So graphing the point 0, 1 is there. 1, 3 will be this point here. 2, 9 will be like way up there. So how am I going to graph x is negative 1, then y equals 1/3? Well, I go negative 1, 1/3 is around about there. And then I go 1/9 will be about down there, and 1/27 about down there. This is what the graph of y equals 3 to the x looks like. It gets big really, really quickly. But over on the other side, what happens is it gets closer and closer to, but never actually hits the x-axis. The x-axis is actually called an asymptote. An asymptote is basically a no-go zone for a graph. This graph can never hit or cross the x-axis. It will just get closer and closer to, but never actually hit it. It will just go on forever like that. The reason it can never hit the x-axis is you can't have 3 to the power of x equals 0. When you raise 3 to a power, you always get a positive number, a number larger than 0. Doesn't matter whether x is, minus 100, it will still be positive. 3 to the power of minus 100 is still positive. It's a very small positive number, but it's still positive nonetheless. So 3 to the power of x actually has to be always greater than 0. So you'd see something similar even if it wasn't 3 to the x. If we were to graph y equals 2 to the x or y equals 5 to the x, it would have the same general shape. This x-axis would be an asymptote. You can't have 2 to the x equaling 0. You can't have 5 to the x equaling 0. The only thing that would be different is 5 to the x would get quicker faster. 2 to the power of x would get quicker slower. But other than that, they have the same general shape. So this is what the graph of y equals 3 to the x looks like. So what about the graph of 3 to the minus x? Well, rather than going through and plotting all these points, we can just see that they are reflections of each other. So when x equals 0, we still have the same y-intercept of 1. So y equals 3 to the minus x will still go through this point here. But the other points are just reflections. See, we know, for example, 3 to the power of 1 was 3. So in this graph, x equals 1, y equals 3. But for y equals 3 to the minus x, it will be x equals negative 1, y equals 3. So it will go through this point here, negative 1, 3. Instead of going through the point 2, 9 way up there, it will be negative 2, 9. And it'll be like way up there. What happens with y equals 3 to the minus x is it goes down very quickly and then it gets closer and closer to, but never hits the x-axis. So y equals 3 to the x and y equals negative 3 to the x, they are just reflections of each other about the y-axis. This is like the line of reflection, the mirror line. So let's now look at the graph of y equals 3 to the power of x minus 4. Well, what we can see here is as x is getting smaller, or if you like, as x is getting more negative, this is getting closer and closer to negative 4. It turns out for y equals 3 to the power of x minus 4, it will have an asymptote at minus 4. So when you have a graph y equals a to the x plus b, this b, that will be the asymptote. Y equals b, horizontal line through b, that will be the asymptote. So for y equals 3 to the power of x minus 4, our b is negative 4. So the asymptote is a horizontal line through y equals minus 4. So instead of having a y-intercept of 1, it has a y-intercept of negative 3. So it goes through there. And then instead of going through 1, 3, it goes through 1, minus 1, and then it goes through 2, 5, and so on. So this is what the graph of y equals 3 to the x minus 4 will look like. So it has the same general shape as y equals 3 to the x. It still gets large really quickly on this side of the y-axis, and it has an asymptote, but the asymptote is at minus 4. It will get closer and closer to, but never actually hit this line y equals minus 4. And that's because 3 to the power of x can never equal 0, so 3 to the x minus 4 can never equal negative 4. 3 to the x minus 4 always has to be greater than negative 4. That's why we have the asymptote here. So these two graphs, the red and the yellow, are the same, except the red graph is just shifted down 4 units to get the yellow graph. That's the only difference between them. Any point on the red graph, you go down 4 units to get the point on the yellow graph. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.